Okay, this is 1.8 on inverse functions. So we begin with this. Okay, so this is 1.8. Inverse functions. And we begin with a definition. Of the inverse functions, and they also call these the cancellation equations. Okay, so we're going to suppose that these two functions, f of x and g of x, kind of undo each other, right? So if you put one inside the other, you get out the thing you put in originally. It's like an identity function for all x in the domain of g. So we'll abbreviate domain of g as big D, little g there. And you also need g of f of x to work like an identity function. So this will output an x for all x in the domain of f. Okay. If that happens, then these two functions are inverses of each other. So you'll say thus, or then g is the inverse of f. We'll note this, notate it. By saying g is equal to f inverse. So that's not an exponent, that just means inverse. It's just a way of notating it. And also in these cases, these domains and ranges will relate to each other. Basically, the domain of g will be the range of f, and the domain of f will be the range of g. Okay. Okay, so the first couple problems, I mean, this is what you're doing. You're composing the functions, showing that they equal, that they become the identity functions, and then you're good to go. Okay, so this is problem 4 in the book. They give us two functions, f of x equals 4x plus 9, and g of x equals x minus 9 all over 4. Sometimes there's issues with, you have to be considerate to the domain and range issue here in the definition. In this case, it won't matter. These functions are tame enough that it's just not going to make a difference. So you'll have f of g of x, and it just comes down to algebra basically. So you're putting g of x inside of here. So x minus 9 all over 4 plus 9 equals x minus 9 plus 9 equals x. And then that'll work for all x in the domain of g. There's just no issues. Okay? So g of f of x. Now you're putting this guy inside of this guy. So you'll have 4x plus 9 minus 9 all over 4 equals 4x over 4 equals x. And again, there's no issues. This would work for all real numbers. Okay? This expression, there's just no issue there. Okay, so thus these guys are inverses of each other. Hence, these guys are inverses. Yay, and they all rejoice, right? Okay. So the next idea is then finding inverses of functions. And it's as simple as swapping x and y, right? So if you're given a function already, you replace the f of x with y. If you have the y in terms of y's and x, just swap x and y, and then solve for y. The book will note if y isn't a function, then there isn't an inverse. Okay, so if y turns out not to be a function, there is not an inverse. Just have a feeling it's a little more complicated than that, but we'll leave it at that. And then, of course, you could rewrite it y is f inverse, and then they want you to check the cancellation equations again. I usually skip the check. I just don't have time. You can check if you want to, though. Okay, so let's look at example 2 in the book. Find the inverse of this linear guy, f of x equals 7x minus 5. So I'll write y equals 7x minus 5. To get its inverse, I'm going to replace the x's and the y, so x equals 7y minus 5, and then solve for this guy. So you'll get 7y equals x plus 5, and then divide by 7 on both sides. You get y equals x plus 5 over 7. And then that will be your inverse function. Okay. Let's look at another one. So this one's a little bit more intense. So example 4, find the inverse of f of x equals x plus 2 all over x minus 3. And of course x can't be 3. So replace the x's and the y. So now you'll have x equals y plus 2 all over y minus 3. You want to solve for y, so multiply both sides by y minus 3. Yeah, x times y minus 3 equals y plus 2. You can distribute there, xy minus 3x equals y plus 2. Collect all the y's on one side, so you can say xy minus y. On the other side, you got 3x plus 2. Factor out the y, so you have x minus 1 equals 3x plus 2. And then divide by the x minus 1. So x can't be 1 in this case. So you have 3x plus 2 all over x minus 1. And you have a restriction on that. Okay. And so that'll be your inverse function. So f inverse of x is this 3x plus 2 over x minus 1. The next section is on the horizontal line test and one-to-oneness. So how do you tell if something's invertible? Basically, it's the horizontal line test that tells you this. Okay, so for example, let's say somebody gives you f of x equals x squared minus 1 and wants you to find the inverse of it. So you try using the method we were trying before. Replace the x and the y, or swap the x and y if you want to read it that way. And then solve for y. So you'll have y equals x plus 1, y squared equals x plus 1, and then you have to do a square root property. So y equals plus or minus square root x plus 1. This is bad news. Okay? And the problem was the original guy was not 1-to-1 to begin with. So what is 1-to-1? Well, it basically just means it passes the horizontal line test. Okay? And the horizontal line test, just like the vertical line test, if you draw any horizontal line, it can only hit the graph in at most one place. And this guy's hitting it in two places, so it's not 1-to-1. Visually, what that looks like, if you remember our arrow diagrams, for a function, we can't have this splitting in this direction. For something 1-to-1, it can't have that reverse splitting. Okay? So when you look at this direction, going from this dot over to here, you can't have this kind of split going on. So this thing right here would not be a function, or not 1-to-1. Okay, and it's kind of related to not being a function. Basically, it has to be a function in the other direction. That's kind of what happened here. You went and solved for it, and you found out the other guy wasn't a function. This is plus or minus square root of x plus 1. This is bad news. Okay, so you can make the thing 1-to-1 if you wanted to, just by restricting the domain. But in the meantime, let's just talk about the horizontal line test. So in particular, here we have an example, the same thing we were looking at, x squared minus 1, so be a little more rigorous about plotting it. So the common function embedded in there is the x squared, and then when you subtract 1, that's going to shift it down one place. Okay, so the end result would be down here, and then neither one of these passes the horizontal line test, so this is not 1-to-1. Another example, the common function we have, f of x is x cubed. Okay, so it looks like this, and this is 1-to-1. And then, again, by the way, if it's 1-to-1, it's invertible. Okay, so once you know it's invertible, to get its inverse function, all you have to do is rotate it about the diagonal. Okay, so this guy will look like this. And its inverse is the common function that we know, the cube root function. G of x is the cube root of x. Okay. Sometimes a little more complicated than that. Let's look at maybe one graph. What you're doing is just interchanging the x and y coordinates. So here's 38. Let's get the original function. It has a point there. -1, it's at 2. And then at -2, it looks like it's at 4. 1, 2, 3, 4. And that has this behavior. Okay, so to get the inverse function as promised, I'm gonna, if this is -2, 4, this is -1, 2. This guy is 0, 1. All you have to do is interchange the coordinates. So instead of -2, 4, I'm going to go 4, -2. So 1, 2, 3, 4, 1, 2. And then instead of -1, 2, I'm going to go 2, -1, 1, 2, -1. Instead of 0, 1, I'm going 1, 0. And that should give you a pretty good idea of how this thing is going to behave. And they should be mirror images of each other about the line y equals x. Okay, so anyways, if you do have a problem with the horizontal line test, you can always do a restriction. So section 5, restrict domains to make them one-to-one. So example 7, we see that quadratic we were working with earlier. And this time we're going to restrict the domain from 0 to, including 0, and then to infinity. Okay? So when that's the case, the picture, or the graph, will just be the one side of the parabola. Okay, so it'll just be this side here. And then to get the inverse, all you have to do is rotate it about the line y equals x, so you get this picture here. We also want the actual function that's associated with this guy here, so we go y equals x squared minus 1 for x greater than or equal to 0, and then x, swap the variables, and you can also swap the variables on this thing here, so you could say y needs to be greater than or equal to 0. Okay. So y squared is equal to x plus 1, square root on both sides, and this time, because y is greater than or equal to 0, you don't have a plus or minus square root. It's only the plus square root because y has to be greater than 0. Okay? So then this thing becomes your function. So we have f inverse of x equals square root of x plus 1. Okay. So that will do you for this part of it.